Hi, I wanted to give a quick tour of this guesstimate model. So the guesstimate model is the expected value of AGI to living, selfish individuals, which means if you were a person, maybe a cartoon supervillain or something, like someone who only cares about themselves, and you were basically interested in the future expectation of your future self in worlds where AI actually happens, or more specifically, the expected value that you'd get from those worlds. This is what this tries to model. So on the top here, it basically tries to figure out what how beneficial life is going to be or negative life is going to be per year that you happen to be around. This kind of is under the condition that you're around for an indefinitely long amount of time, when indefinitely means until the AGI actually dies. So basically, the idea is that there is some chance that an AGI will happen, and this is explained here. There's some chance that an aligned AGI is created, that the AGI will keep living individuals around right now until basically the end of the AGI's life. The thought is that this will maybe happen in negotiations around a singleton, or whoever makes a singleton will actually desire this and will just be locked in. And also that this one individual as a human, happens to be alive when this actually happens. There are, of course, situations where the person is dead but has cryonics. I'm not really factoring that in, and I think that it's like small in the scheme of things. So I'm kind of claiming that there's about a 0.01% to a 1% chance. Of course, this assumes a bunch of things. I think that this may be kind of low. I know some people would say that even a 7% chance of AGI being good is like kind of reasonable, and that's even like kind of a low thing. So if there's a 1% chance it's good, and then like a 1/100th of a chance in those cases that you're kept around forever, that would be a 0.01% chance. Um, yeah, but this node, of course, is like all the nodes, there is some variability to. In this case, what I'm looking at is equalities per year positive outcomes, which basically means like in the positive outcomes, in these scenarios where you're kept alive for the span of the AGI, how good is every year going to be? And what my thinking is that it seems really easy to imagine with great technology, an individual getting to be about 10 times as happy per year, or is like satisfied, or whatever moral framework that you're looking at, in general, 10 times as well as what's currently being done seems pretty easy. 1,000 times also seems like very much on the verge of possibility. My guess is that if anything, it could be quite a bit higher than this. But that gets down to a question of like, what exactly are we dealing with? Are these humans? Like, what exactly is a human? If they just copy themselves 1,000 times, would that still count? I'm kind of saying no in the idea of a selfish individual. But feel free to, of course, change this node or change any others when you're going through this. And you just basically multiply those two to get the net expected total qualities per year until the end of universe, which means basically at this point, the expected value of an AGI is around 0.73 qualities per year for the lifespan of the AGI, assuming these other variables hold and assuming that the model is kind of accurate. In the negative outcomes, my impression generally, and I write this in the blog post, is that there's a smaller chance that a negative outcome is going to happen because it seems like a very bad idea and humans would have to mess up quite a bit. And this is not a negative outcome. This is like, even if a negative outcome may happen to some people, my guess is it won't happen to the majority of people. And if it does only happen to some people, then that would be like less likely per person. So I think it's less likely, but I'd be curious, of course, to hear feedback. Over here we have the qualities per year. This is basically the negative qualities per year, so zero point 0.2 to 500. The question, of course, is how much torture could someone feel? But to be more specific, the question isn't how much torture they can feel, but it's more like how much they will feel in these hypothetical scenarios. That is also something that I'm kind of unclear about, but I don't think is that positive. So in this case, that winds up with like negative zero point 0.2 qualities per year for the end of the universe, or until the end of AGI. And this is like, it's definitely smaller than the positive, but it is probably still pretty bad and still worth thinking about, because this is a pretty large negative value, right? So like the expected value of this negative thing is pretty horrible, even so. So that, just summing these gives this result. Now I'm going to go to the bottom of the model. So in terms of future predictions, This guy is when years from now when AGI will start. That just has to, that's useful for the next few calculations. It doesn't actually come out to be that impactful, so it's not that important. You could change it, but I don't think you'll change much. This is probably one of the big ones here. The expected years of the universe left where the individual will still exist. I've read a few, you know, online articles about how long the universe has lived for and how long the universe may live for. My general impression is that the range of 1 billion years to 100 billion years seems like a reasonable start. That said, this variable doesn't actually make that much of a difference in terms of you need quite a few orders of magnitude to make a big difference to the eventual impact. So if getting it to be more narrow is not actually that important. One area where it could be important is like if it comes out that this is several orders of magnitude bigger because an AGI is able to escape the universe and figure out, go to the multiverse or do something else. And that's probably worth thinking about a little bit. This here is a hyperbolic discount rate for an individual. I think this is actually a little bit low. I've been playing with this a bit recently and moved it down for experimentation, but I'll move that up in the end, and you'll see that it makes almost no difference. The expected years with discount rate is basically how many expected years, how much do you value these future years, and that just takes this into effect. And basically, the actual math for this you could see based on a link on Wolfram Alpha, where I just took the integral in order to figure out the total expected value because the hyperbolic discount rate is applied. It basically makes every year in the future a little bit less useful. So what does that whole expected value look like for this set of years? I think this is a correct math, and according to that is 860. Now, this guy's kind of interesting for sensitivity. If you zoom out, you'll see that most of the variance of this distribution basically comes from this node, which a linear extrapolation would account for like 0.93 of that. And that one basically completely comes from this one. The R-squared values do come from linear extrapolations, so those don't hold when something is not linear, as is true for this. But I think it should be pretty obvious that this is like a pretty important variable. If I'm going to go to viewing mode, and this makes sure that my edits won't change anything. So if I change this to like 0.001, you'll see like basically every order of magnitude does create a bit less than an order of magnitude in terms of extra years. But we are talking about like insanely low amounts of discount rates. Like very, very few people that I know would say that the discount rate shouldn't be 0, there should be 1, but it should be about 10 to the negative 5th, right? That's like a pretty intense claim to make, as opposed to 10 to the negative 8th or 10 to the negative 3rd. So in real life, we have discount rates of about, if anything, about like zero 0.04. So even if you were one small fraction of that, you still compress 25 years down into just 15,000. So finally, I want to talk about this final node, and this is very straightforward at this point. We have the total number of years, and we have the amount of expected qualities per year, so you just multiply those two together and get the total expected qualities. If we expand that guy, we could start looking at what numbers would match with different percentiles. So 410 is a mean, but of course so there's a very wide tail on the right side, so that'll influence the mean. The 50th percentile is about 51, right? So, and if you start looking at kind of reasonable percentiles, like maybe a 90th would be kind of 1, or a 70th is 1. In these cases, these numbers aren't that high. So even the 90th percentile is still about, still about 1,000. The median is 51. I think that numbers from about 50 to 1,000 are surprisingly low for a chance at living forever in a very good condition. But I'm, of course, curious to hear what other people think. And I'm also curious to hear what nodes people are going to complain about the most.